Good morning, good afternoon. Welcome to our first Ask Tom session of 2024. We're welcomed today by Karen, who's going to talk to us about finding valuable spatial data sets. Karen is a product manager with our Oracle Spatial and Graph teams, and this slide deck in particular has a significant number of links, and we're going to add them to the recording. So you can get them. So we just wanted to highlight how to get to the spatial stereo and Ask Tom. Oracle recently released a new version of Ask Tom, and we wanted to show you that when you're in the Ask Tom session, you can find your spatial for DBAs, analysts, and developer office hours here. I'd like to highlight that the February session is a nice follow-up to today's review, and we're going to go into how to touch or how to use the tools with these data sets that we're going to go over today. Next slide. And if you have any questions at all during Karen's presentation, please don't hesitate to put anything to the Zoom Q&A box. We have a number of panelists that will help answer your questions. So without further ado, you want to take over, Karen?
Sure. Thanks a lot, Denise. I just want to highlight something at the beginning, kind of disclaimer, and bear with me that it's not the official disclaimer, but I'm going to show you a few links pointing to publicly available data sets. And if you make use of those data sets, please make sure that you check the terms and conditions to use those data on your own. It's something what I've collected over the past couple of months and years, valuable data sets I've been using for demo purposes mostly. So it's everybody's responsibility to check how you can actually use the data I'm pointing you to. Okay. So I've made available some scripts and also some data for this session in this GitHub repository. For those of you who have joined a previous session of mine, you have seen already that I have this GitHub repo with for the Ask Tom sessions, and there are some additional information like scripts, like also some data you can work with, and you can find the scripts and data for this session under in this folder for the session 20 or January 2024. And I also want to remind you, for those who don't have an Oracle database in place somewhere locally installed, that you can also use our geospatial data platform deployment on the Oracle Cloud. It's very easy to spin up an environment that provides you with a database. In this case, it is an autonomous database, and with additional tooling and as tooling we've made available via this via this architecture and deployment that you can use a Spatial Studio together with your autonomous database as well. So easy to do. Just go to that link and either choose to deploy directly to the Oracle Cloud to create a stack a Terraform stack that actually sets up all the required resources, or if you want to check it on your own and modify it, then go to the GitHub repository and check the Terraform scripts over there and use it as you use them as you like. Okay, what's on the agenda for today? I just want to briefly recap what you've learned already in the previous sessions. And this time, I just want to highlight again a few things about vector data. Then I want to go with you through the different data sets and what kind of data they are and what purpose they serve. And mainly we will be talking about vector data, raster data, 3D data, or Geo Web Services. And I'm also briefly touching upon the tools to load those kind of data, but this is just briefly, since the next session, Ask Tom session in February, is meant to go into more details with regard to the tools I'm going to just mention today with a few more information. And at the end, there are a few more links to learn about more, or where you can ask your question, those kind of things. And of course, the Q&A, as Denise mentioned, you can use the Q&A part of this Zoom session to ask your questions. Okay, just a brief reminder and recap on spatial data types. When we talk about Oracle Spatial Technologies and about spatial data, then there are several data types we do support with their own complex data types or data models, such as vector data, network data, raster imagery, 3D data, topology or streaming data. Those are actually different types of data we do support with Oracle Spatial at no additional cost. So everybody who has an Oracle database in place up and running can make use of the features related to these types of spatial data. We are not going to talk today about topology data or streaming data, but the other types of spatial data I've prepared information for. Okay, so first, one starting point to get data sets you can work with together with the Oracle database is to check the Oracle Technology Network. And there's a link pointing you to spatial data sets provided by Oracle partners. And there are several data sets you can access there. But please note that these are not Oracle supported products. They are provided by Oracle partners. So please check with those partners if there are any problems, support issues, or also check, as I mentioned before, the terms and conditions to use this data. Some of the offerings are currently under review, so we're going to revise the listings and update them if there are new offerings available, or if there are any changes to currently existing offerings. Let's start with having a look at different vector data sets that are available and which I've used in the past to do demos, projects with customers, projects with partners, and I wanted to actually share those kind of things. But before I do so, also brief recap on vector data and the different types of vector data. You probably remember the term of simple features, which is actually a synonym for geometries for vector data. So information that you can represent as points, lines, or polygons in the Oracle database using the data type geometry. And we have seen in a previous session that there are plenty of different formats for this type of data, for vector data. So shapefiles, KML, GML, GeoJSON are common data common formats for vector data. And when you later look and follow the links I'm going to share to find vector data sets, you typically have also filters in place where you can choose to have GeoJSON or shapefiles or maybe even CSV files, so comma-separated files with longitude and latitude values. So please make sure that you are familiar at least a little bit with the different formats, because you will be asked what kind of format you want to download when you want to use a specific data set. One thing that is not provided as an external data set, but something I'm going to show you what you can do on your own. You can actually use pure SQL code to generate your own data sets. And this is something which what you can very easily do for point data. Point data are easy to handle because they typically have either two coordinate values, longitude, latitude, X, Y, whatever you want to name it, or in some cases also a third dimension, but you have just the two or three values you need to consider to create geometry or vector information. So, and for this, I've created several scripts to add actually a large set of point data covering the whole world, or restricted to a given bounding box. So you call actually the pure SQL script, the second one, with additional parameters to define the bounding box which you want to use to place your point data in. And since we have already seen in our previous versions how we can visualize spatial data, and one of our tools to visualize spatial data is Spatial Studio, I've just extracted here or put here in a view on those artificially created point data that are bounded by a bounding box and displayed with a Spatial Studio. And I just want to mention something. I've done several performance tests in the past to create large amounts of point data, and it takes a couple of seconds, maybe a few minutes, to create very large point data sets spanning several millions of points. So this is a very easy way to create artificial data sets. The next data sets I'm going to talk about, I just want to remind you also that when you download data sets provided by external parties, please, and you load them into the Oracle database, please make sure that you validate the data. You've seen before that we have the simple features definition for vector data, and this includes that data need to be valid in order to give proper results when working with the data. And to validate your data, you can use the SDO-geom package together with methods that are available in this package, like validate a geometry with context or validate layer with context. I've talked about these this package and the methods to validate data in one of our previous sessions when I talked about best practices. So maybe you want to go back and check that session to get further information on it. And if you find incorrect or invalid geometries, I strongly recommend to correct the geometries if possible. Okay, so the data sets I've actually clustered a little bit according to what kind of data they provide. And one of the very first starting points typically is that we need to get geometry information or the admin boundaries of countries or other administrative levels for those countries. And for that, you can use the world data sample provided by Oracle Partner here, which is available via edelivery.oracle.com. So the link here actually is on Oracle Technology Network, and from there you are guided to edelivery.oracle.com, and from there you can download this. Let me check. This data sample, which provides administrative boundaries for the whole world, and also including road data, major road data, rivers, and other types of vector information. It's quite a large data set, and if you unzip it, you can see that here is a data pump file, so an export of the world data sample that you can import with Oracle Data Pump. There is also a README that provides you with the information how to deal with the data set, and also a script load sample data that creates you a user called world sample where the data are loaded into. So what you need for to load this data set is the data pump. So the import tool of Oracle Data Pump, either via the Oracle Instant Client or from Oracle Database installation. When it comes to country data sets, and if you want to have a specific country only, I found it very useful to check this provider, GADM.org, and there you have a filter to select the country you're looking for, and then it provides you the administrative boundaries for the different countries in several formats. And typically you can either download it as shape files or as GeoJSON. So those are typical formats provided for the country-specific administrative boundaries. Also, an important aspect of spatial data, and you want people want to work with, for example, when it comes to either test the geocoder in Spatial Studio or the geocoder that is provided with the autonomous database. Then the question is, where can I find address data which I can use to test the geocoding function, or if I want to just get a sample of address data to do some kind of spatial analysis, then there is this openaddresses.io offering where you can download data sets that are free and globally available. There's also a GitHub repository with further information on that. Please make sure that you register to access these data sets. The registration, as far as I've seen, is free, so you are not charged in any way, but registration is required. What you can find there are actually typically data sets for buildings, so just general addresses, and also parser information. So parser information typically are geometry polygon data sets. So here are a few more information. So also you can see here that you have the data in different formats: shapefile, typically GeoJSON or CSV. Another interesting resource for vector data or water bodies or weather data. And when it comes to water bodies, we've recently used this marine regions offering to download all the shape files or all the geometries that form the water bodies, oceans and seas worldwide. And so for my purpose, actually, I've downloaded here the IHOC areas and shape files for it, and uploaded it into the Oracle database. And here, if somebody requires to use those type or these information and these geometries, again, strongly recommend to validate the data, because there are some invalid water bodies, so you need to do some correction before. There's also this National Hurricane Center, which provides data about hurricanes and storms, which are serve very nicely to do spatial relationship analysis. So you can go there and download the paths for specific hurricanes or other types of data. And if you want to look into weather data, there's, for instance, the offering of the National Meteorological Service in Germany. They have an open data portal which is filled with plenty of data, with current data and also forecast data. So if you need those type of information, then I can recommend to go there and download the data from there. Also, very nice resource to actually get vector data that aligns or multi-lines is looking for railway and road data sets. And one of those providers is the German Railway. They have an open data portal as well. And there you have these geodata sets here, which are typically either GeoJSON or shapefiles, and you can download the data sets from there, and they are also free to use. And there are not only the tracks for railways, but also station information and those kind of things. So you can create your own maps with stations and railway tracks as well. And of course, do useful analysis with it. Ordnance Survey UK is also a very useful resource where you can find plenty of data sets. So it's OS Data Hub, OS UK. And here is a sample data set with major roads. You can download from there. Generally, UK provides a lot of publicly open data. So if you go to data.gov UK, you can find other data sets, and among those are also railway data sets. And then there is a collection of different data sets, which is comprised under Open Data Soft. And if you go there, you can find a list of railway stations with their coordinates in Europe, which you can download from there and import it. Also very often used are zip code areas, and they're not often free available as open data, so you need to somehow look where you can find those data. But one of the providers for publicly available zip code data geometries is the US Census Bureau, and there you can download zip code areas for the United States. And there are also some data sets available if you are a Python developer and you want to actually load data using Python spatial data. There, Python and especially Spatial comes with sample data, and you can see which sample data are available via importing the libpython examples library or package, and then you just check the available data sets with this call available, and from there you can actually upload those data sets as well. And the data sets provided via Python are originally from the Center of Spatial Data Science at the University of Chicago. So you can also check their web offering. OpenStreetMap, I assume you're familiar with it, is also very common and often used data provider, mostly starting with background data, but also as a source of specific information which you can download either directly from OpenStreetMap, so you can check an area there and download data directly from this OpenStreetMap website, or there is additional provider that for data extracts from the OpenStreetMap project called GeoFabric, and GeoFabric also provides you with an interface to define what kind of data set you want to, and you can download it from there. If you want to use spatial data in relation with market data, there is an offering of the GfK geomarketing, and there you can request the market data together with spatial data via this form. So it's not longer on our website, but you can freely request a sample data set for different purposes. For example, if you work in the finance industry or then you probably are familiar with the term of cluster zones and finance and insurance company. And these are sample data you can download from the GfK websites. The next data sets are actually a mix of vector data and other data types. So before coming to those other data types, I'm going to just add a few more links to those data providers who provide different data types. So again, the Ordnance Survey is a very recommended source of mine to check availability of certain spatial data. Also, the Canada provides a lot of free and open data, spatial data. So here is one starting point to get those data. And if you're based in Europe and have an interest in European data, just go to the European Open Data Portal and check for the data formats you are specifically interested in. And here you can see in the background they provide shapefiles, GML, GeoJSON, and other formats as well. Also a source of mixed data, and here with a focus on also on raster data, especially imagery data. You can, ORCID has a collection of freely available or open data in their open data portal. So if you go to opendata.oraclecloud.com, you find several geospatial data sets for natural Earth, temperature data, so again, weather data and other data sets. So just check the offering and see whether you can or want to reuse data provided there. The USGS Earth Explorer offering is there also to for you to extract data sets you're interested in, or of course, very rich source of available data is also ArcGIS, Esri's ArcGIS, and you can just go there and check the offering. ArcGIS is giving you to download and work with spatial data. Okay, raster data sets. So specifically looking into imagery or weather data, and here I can recommend, beside what we have seen before on the Oracle Open Data Portal, there's also geography, where you can download satellite data provided, or Sentinel-1 and Sentinel-2 satellite data, and you have as well the chance to select the data you want to download and make sure that you get the scenes, the imagery you are interested in. Then, specifically for the Netherlands, there is an offering at geotiles.nl, which also provides raster data. So just go there and check what types of raster data or what kind of raster data you can get for the Netherlands. Okay, so let me go briefly through some 3D data sets, and I want to start with, similarly to what I've shown you for the 2D vector data, that you can also create 3D data code generated. In this case, we actually have a 2D data set, which is are polygons, and if you have such a data set, for example, the footprints for buildings that are 2D, you can take this data set and extrude it to be 3D. So what you do there then is simply adding the third information, the third dimension, which is the height, to the geometry. And here on the right side, you see how you can actually do it. So we have creating a table with the extruded 2D information, and then you can just select from the 2D information. So here, building footprints, and then add a specific height to that, to those geometries, and this will provide you with 3D data. If you want to work with LiDAR data, which are laser scan data, then I can recommend, again, provider in the Netherlands. So the University of Delft is very experienced in creating and working with LiDAR data, and also providing tools to work with LiDAR data. And they have actually available the whole LiDAR data, or complete LiDAR data sets for the whole of Netherlands. And if you go to the offering geotiles of the Delft, then you can see here that you have the different data sets available for download. And if you are not familiar with the extension for those files here, those are LAS files or compressed LAS files. So LSAT is the compressed version of LAS files, and there is a tool set available to work with LiDAR data in terms of loading also those data set into the Orica database, which I'm going to touch briefly a little bit later. There are also LiDAR data available via the NOAA, and now I need to, Hans, I think you you can, would you please just add the whole term for NOAA into the chat so people.
Yes, I'll be happy to do that. No problem.
Yeah. Okay. So it's National Observation. I don't actually remember the whole term or the whole name of the organization exactly. Okay. Okay, and there is also a collection of data sources brought together here on this landscapearchaeology.org. And if you're specifically looking into LiDAR data, just check out the data sets that are linked into this page. Okay, and last but not least, I also want to touch on the Geo Web Services. Geo Web Service typically are image information. So the format is either either PNG files or JPEG files, and the web map services specifically are very often used as background maps. So you have probably seen, if you've looked into Spatial Studio, that you can use web map services as data sources and then use create data sets from those data sources, and those data sources can then be data sets can then be displayed in Spatial Studio. So if you want to use, for example, a web map service with OpenStreetMap data, you can go and see what Terrestris is offering. They actually have a web map service for the OpenStreetMap data you can use, and the information are provided here. There's also web map services via National Ordnance Survey agencies, and here's an example for web map services provided for Germany. So Hans is very much familiar with this information because it's his hometown, Hamburg, here in Germany. But typically, if you check out the National Ordnance Survey agencies, they have offerings for geospatial or geo web services, and this includes web map services, but also other services as well. But since web map services are very often used for background as background maps, I've included an example here as well. And again, NOAA also provides a lot of data sets actually as web map services or as web feature services. So just check it out there. Okay, so you've seen there are plenty of data available. Not all the links you can find if you search for a specific data sets are still valid. So sometimes they are either not longer valid or it's the data are not longer open and public. So the links I've provided until in the previous slides, they are checked as of yesterday and today, so they are still current and available, and hopefully will stay so for the foreseeable future as well. Let me check. Are there any questions regarding the data sets so far which hasn't been answered yet? Maybe it's a good time to check on that. Hans, do you have an overview of what's still open as questions?
There was just one question on administrative boundaries, and as you touched on administrative boundaries straight after the question, I think that was covered.
Okay.
And the rest, I think, is clear.
Perfect. Okay, then let me go ahead and also briefly touch upon the tools you will be typically using to load the data sets. And I mentioned already that Spatial Studio is there at your fingertips. You can download it, use it for free. And Spatial Studio provides an interface to work with several of the data sets and formats I mentioned before. So here we have CSV, spreadsheets, shapefiles, GeoJSON, KML, or files you can directly, or data formats you can directly upload and store into the Oracle database. What I haven't touched upon is Cesium, so another 3D data format you can directly upload. On the left side, you can see that there is also the option to directly access JSON or data provided as JSON data via the URL, or also access directly Oracle OGC Map Services, so creating a data set, as I mentioned before, for the NOAA or the National Ordnance Survey Agency web services. This is something you can create via this interface. When it comes to load spatial data that are provided as textual information, and typically CSV files or well-known text, this is something you can easily do with SQL Loader. And this is on the right side, there's actually an image that refers to this part here, but let me first explain also the second topic. Oracle also provides a so-called shapefile converter together with the Oracle database, and the way you use this shapefile converter is described in the Spatial Developer's Guide, and I'm going to show an example of that during the next session. And now, what the actual the image here is referring to, you can also load spatial data via the external tables support in the Oracle database. So if you create a table that is pointing to an external data set, you have this clause here, organizational external, and there you define certain parameters, and as part of the parameters, you also have the definition of the fields you want to load. And in this case, we actually have a CSV data file that contains the longitude and latitude value as numeric values. And you can define your table pointing to that external data source, or even using that external table to actually create your own database resident tables by actually inserting data from that external table. As part of the tooling we also provide with the Oracle database. We have a Geo Raster tool, actually a Geo Raster loader that is installed together with the Oracle database examples. So if you have a plain Oracle database without any without installing the database examples, you won't find this demo subfolder underneath MD for multi-dimension in the Oracle Home. So this is missing for plain Oracle database installations. But if you install the Oracle database examples, then there is this demo, the demo folder will be created, and it contains several tools to work with spatial data. And one of the tools is this GeoRaster ETL tool, which allows you to load single or more than one raster files into the Oracle database. And there's also a tool called GDAL, and we ship GDAL together also with the Oracle database in the Oracle Home /MD folder. And it needs a little bit of configuration, which is described in the user Spatial Developers Guide. And I'm also going to show that in the next session in case you haven't used it yourself. So GDAL is actually also an open source tool, very often used to work with several types of spatial data and several formats. And let me just briefly show a few examples of how you can load spatial data using GDAL. So GDAL comes with Oracle drivers for handling vector data and raster data. And here is a slightly or a blog post that touches upon loading raster data. So if you have GDAL installed and properly configured, then you can just call GDAL.formats, and it gives you all the formats that are supported for GDAL. And one of the tools is OGR to OGR, which is actually the tool to import different data sets from which does the automatic translation from one format into another format. And OCI here is the actually the prefix in order to load the data into the Oracle database. And you are probably recognizing that there are a few parameters. One of the parameters is the database connection with the username, password, host, port, and the database service name. And then you have the data set you want to upload. In this case, it is a shapefile. And you have more parameters which you can use to define the dimensions, the coordinate system, and how the geometry column will be named, and whether the spatial index will be created or not automatically. So those kind of parameters you can define when you use OGR to OGR. So this is file-based import. And here, the second example for OGR to OGR is actually an import into the Oracle database from a Postgres database. And it's similar to what I've explained for the file-based import. We've seen that there are very large 3D data sets available, and especially LiDAR data sets are becoming more and more popular to work with. And I already mentioned that there are tools to work on to work with and specifically load LiDAR data into the Oracle database. And one of those tools is actually a set of, or actually a tool set provided by a Rapid Lasso, and this is called LAS tools, and you can find it via this LAS tool github.io. And the tool set actually contains different methods to work with LAS files. And as far as I remember, in one of our last sessions, we had an example for working with LAS files. Yeah. But here you can see a call how you can load LAS files into the Oracle database. It's a little bit similar to what you've seen before using GDAL. Okay. As I mentioned before, I want to go into more details and show examples of how to work with those publicly or available or open source tools like GDAL, like LAS tools, but also others like QGIS in my next session, end of February. So please stay tuned, and hopefully you can make the time to join that session as well. This is what I wanted to present today. Just let me finish with a few links where you can find more information. It's either on general information on oracle.com database Spatial. If you want to try things out on your own, I strongly recommend to look into Oracle Live Labs and search there for Spatial. And I mentioned the documentation, the Spatial Developers Guide. The link for that one is here. And also, again, the link for setting up geospatial platform on the autonomous database in the Oracle Cloud. And that link is provided here. We do regularly post about spatial and spatial features in that blog, Database Insider blog. So check the category Spatial over there. But we also do it on medium.com and other blogs as well. And all relevant content where we have some recording for, you can also find on Oracle on YouTube. Okay, so just the last slide for today from my side. If you have a question, then we ask you to post your question either on Oracle forums or Stack Overflow. We review those forums regularly to be aware of what you're interested in or whether you have any kind of problems. But actually, in case of problems, I would recommend to use my Oracle support to create a service request over there. But if you want to ask a general question, then these two forums are a smart way to post those questions. Okay.
Good, Karin. Talking about questions,
yep.
We had an interesting question in the Q&A, and again, everybody is welcome to put more questions into the Q&A. The question was about using, not using data from websites, but rather using location data from mobile phones. So positioning information from a GPS sensor of some sort in Oracle Spatial. And I just wanted to make everybody aware that with the possibility of function-based indexes, what you can do is you can upload the longitude, latitude data from GPS sensors straight into a table. And then on top of that table, you can create a function-based index, and you can do all kinds of spatial analysis or spatial processing using latitude, longitude as is, essentially, without converting the data physically into SDO geometry objects for all kinds of purposes. And the easiest way to achieve that is, once you've loaded the data into latitude, longitude columns, is to use Spatial Studio and create an index on latitude, longitude. That is an option in Spatial Studio when you create your data set. Or when you spatially enable your data set, I should actually say. So if you want to give that a try, that is pretty straightforward and much less hassle than what we had in the past, where you had to essentially manually create the function-based the function and then create the function-based index and all of that. So Spatial Studio takes care of all of that work for you. That was the thing which I didn't want to explain in great detail in chat, but if anybody is out there who wants to try this and has problems with that, feel free to ping us. You've got the links, you've got the Twitter handles, or even the email account, so feel free to reach out to us.
Yep. Thanks a
lot. That was all
Hans.
I wanted to say.
Maybe it's a good thing to have a special session, as Tom session, for that topic as well. Maybe we can add it to our list.
Yeah, we may actually have covered this topic in one of the Spatial Studio sessions a while back, but it may be worth revisiting this kind of thing just so that everybody is aware of what you can do with Spatial Studio for the purpose of loading spatial data wherever you got the data from. If it's not terabytes and terabytes of data, then using Spatial Studio is actually an elegant way to just upload what GeoJSON or shape files or what have you. And X and Y coordinates could be one option.
Yeah.
Sorry, Karin. Yes. Go ahead.
I just want to hand over to Denise.
Thanks, Corinne. Thank you for that. That was wonderful. And just a reminder that our next session is February 27th. And as we mentioned in the beginning, we'll be going over those GIS tools that Corinne briefly touched on. Without further ado, everybody have a great day.